Have you ever pondered the inner workings of an inductor, capacitor, and resistor when they're strung together in series with an alternating current source? It's a fascinating exploration into the world of electronics that reveals the genius behind our modern technological conveniences. First off, let's tackle the inductor. Picture a coil of wire wound around a magnetic core. When an electric current flows through this coil, it creates a magnetic field. But here's the kicker. An inductor opposes changes in current. So, when the current increases, the inductor produces a magnetic field that opposes this change. And when the current decreases, it does the opposite. This property of an inductor is called inductance, and it's key to many of our modern electronic devices. Next on the docket is the capacitor. It's a clever little device that stores electric charge. Consisting of two conductive plates separated by an insulator or dielectric, a capacitor charges up when a voltage is applied across its plates and discharges when the voltage decreases. This ability to store and release electrical energy makes capacitors indispensable in electronic circuits. And of course, we can't forget the resistor. This is the component that opposes the flow of electric current. It's essentially the traffic cop of an electric circuit, controlling the amount of current that can pass through. The opposition a resistor provides is called resistance, and it's measured in ohms. Now, what happens when you connect an inductor, capacitor, and resistor in series with an alternating current source? You get a circuit that resonates. This is because the inductor and capacitor constantly exchange energy between each other, creating a flow of current that swings back and forth. The resistor, meanwhile, dampens this oscillation, reducing the amplitude of the current over time. In essence, the inductor, capacitor, and resistor work together in an elegant dance of electric charges. The inductor opposes changes in current, the capacitor stores and releases electric charge, and the resistor controls the flow of current. Together they create a resonant circuit that can oscillate at a specific frequency, determined by the values of the inductor, capacitor, and resistor. So, the next time you're marveling at your latest electronic gadget, spare a thought for the humble inductor, capacitor, and resistor. These seemingly simple components are the unsung heroes of our electronic age, working tirelessly behind the scenes to bring your devices to life.